All right, so we're looking at some application problems today. And so a lot of the issue with application problems is that there's this translation between what the English is saying and what the math that you need to do is. We don't talk in those math terms when we ask these questions. So we got to have like ways of looking at the problem and saying, what are they actually asking me to do mathematically? And so what are the words that we use to talk that would imply certain math things that we need. Okay. And week and a half ago, 2 weeks ago, when I first started talking to you guys about quadratics, I briefly talked to you guys about like some applications of quadratics. There's projectile motion. Anytime that something jumps, because it get kicks, thrown, launched, but in a way that there's not like an engine on it still, right? It's not getting continuous energy, just that one impulse of energy, then it's free flight through there. Okay. Those things fly in the path of a parabola. A lot of parabolas are used structurally, like the St. Louis Arch, or if you look at a suspension bridge. So they have the two towers at the end of the bridge, and then they hang the cable between the two towers. That cable hangs in the path of a parabola, okay? And then they suspend these wires from the cable, and then those wires then hold up the road, or whatever the walking path, whatever it is, whatever the bridge is for. So that's why it's called a suspension bridge, but that top cable hangs in the path of a parabola. So if we needed to know stuff about it, if there's any little creature that's jumping or, again, a ball being kicked or thrown or anything like that, that it would move in the path of a parabola as it's moving through the air. Okay. So what are things that we would want to know about these structures, about, we talked about satellite dishes and your eyeballs, like with glasses and stuff, the glasses are shapes like parabola. What are the things we would want to know about these structures or objects as they're moving that we'd want to talk about, right? Like if we're talking about, how high does the animal jump, right? It's a pretty normal question to ask, right? What part of the math is that, right? Or how far does the animal jump, right? How does that correspond to math? And so when we use words like maximum, minimum, right? You say max, okay, what's the max value of, what's the highest that animal's jumping, right? What's the lowest that cable dips down, right? So those are vertex questions, okay? If we want to maximize something, right, there's that maximum again. Okay? If we want to think about the highest point or the lowest point, anytime you talk about stuff like that, we're talking about the vertex. Okay? We don't say vertex. We have these other terms for it that imply that we're looking for the vertex. Okay? So when you see these words in the problem, it's really saying, hey, this is a vertex question. Okay. Well, what else could we be interested in, right? Zeros, solutions, ground level, width, distance, how far, right? How far, right? How far did the animal jump? Well, if I know where that point is and I know where that point is, right, then I could say how far apart they are, right? Then I know how far the animal jumped. If we think about this, if this was my x-axis, then those would be the x-intercepts. So how far the animal jumped corresponds to where the x-intercepts are. Okay? Distance, right? What's the distance the animal jumped? Or what's the distance between the two towers, right? How far does the bridge span? Okay, so if that was my x-axis here, right, then those would be my x-intercepts. And so then I could know how far apart those towers are based off of the x-intercepts, or distance or width. What's the width of the river or something like that? You could ask that question. We also talk about things moving through time. Okay, so if instead of the object moving through space sideways, if it moves through time sideways, we can talk about how long the object is in the air. Okay, or like how long until it hits the ground. Okay, so that's something else we could say. We can talk about time, amount of time passed, how much time. So those could be other questions that would deal with x-intercepts. Okay. Big thing that I think will be really helpful for you guys, in making sense of the problems is this tip right here. Okay. So if you're writing this down, I would go ahead and write this down, or at least parts of it here. So I'd underline and circle what the question's asking for. I'm gonna be doing a lot of highlighting here today. Okay. And then I would write down what the X and Y coordinates represent. Okay. This is going to help you decide what part of the math you need to be talking about. Okay. What am I actually going to find? Because if I find the vertex, which part of the vertex, is it the X part or is it the Y part that I actually am interested in? Because that can change on how much work you need to do. Okay. So I really would suggest that you guys are doing stuff like this, that as you're breaking the problem down, making sure you're making sense of what you're being asked for. Okay. It's going to change so much for you. If you don't know what you're looking for, then I mean, how the heck you got to find it? Okay. Let me know if I'm at all moving too fast, because I know some of you guys are writing stuff down. So, but as we look through the problems, I'm going to talk to you guys about, if you are writing them down, what you need to write down. So you don't need to write down a whole bunch of this stuff. Okay. So in this first example, so we have our function. It models the jump of a red kangaroo. It says the X is the horizontal distance in feet. The Y is the corresponding height in feet. What's the kangaroo's maximum height? So if you think back to that tip, right? Underline what the question is asking for, circle what the question is asking for. What's the max height? Right? I don't need to know that it's a kangaroo. Right? So if I need to write something down, there's the question. What is the max height? Okay? What else do we need to write down? Okay. What does X stand for? Horizontal distance in feet, or even, why do we really need to say horizontal? Of course, X is horizontal. All right, so X is the distance in feet. All right, and then Y is the height. I don't need to say corresponding. All right, so Y is the height in feet. So if I'm trying to limit the amount that I need to write down, okay, I can write it that way. And of course, I need the function. Okay. But to do the math, I don't need to know that we're talking about a kangaroo jumping. I know that I have a parabolic path that represents distance this way, height this way, and then I want to find out its maximum height. Okay? So that's the minimum I would need to write down in order to be able to do the problem. Does that make sense? Yes, no? Yes, no? Some fanatic nods out here. Okay? So what are we actually after? Okay? How do we make sense of this problem? What do they really want from us? Okay? Sometimes it can be helpful if you draw a picture, right? We're talking about something jumping. Okay, so we starting here, right? Jumps, moves in that path of a parabola. Okay, we get to decide where to put the axes. It's completely up to us. It's completely arbitrary. Okay? There's not a real set of axes out there that we would be looking at. Right? We have this object. It's moving through the air, lands on the ground. Where should we put the axes? I can put the y-axis here, and I can put the x-axis there if I want to. Is that going to be helpful though? Okay, probably not. If we think about that x-axis and what it might represent, where it would be helpful to be in real life, right? If we think about the ground, right? It's an object that's leaving the ground, hitting on the ground again. So if we think about the x-axis being the ground, it can make more sense, right? That's where 0 would be as far as the y values, right? It makes sense for the ground to be 0 feet above the air. And then generally we we think about things being positive, right? The kangaroo is not jumping negative 25 feet anywhere, right? So we want positive values for the distance. Well, the positive side is the right side. We want the y-axis to be on the left so that everything to the right of it is positive. Okay, we get to make all these choices though. Okay, but what's make the most sense to us? So we want the graph to be above the x-axis so that it's a positive jump. We want the graph to be the right of the y-axis so that it's positive distances. Okay, the math doesn't care though. All right, what does that axis represent? Represents height in feet. What does that x-axis represent? Represents distance in feet. Make sense of this. Okay? The more you draw, the more it'll help you make it more concrete, get it out of your head, get it out of the words so you guys can see it. Okay? Make it more concrete by seeing it. Okay? What are they asking for? The max height. Well, where's the max height? All right, what does maximum mean? What's maximum connected to? They're asking for our maximum, what they're really asking for. What's that?
How high finger jumps?
What's the highest one? A vertex. This is a vertex question. Okay? They're asking about the vertex. Well, what part of the vertex are they asking? The height. Is the height x or is the height y? It's the y, right? So they want to know about the vertex, but very specifically, they want to know what the y coordinate of the vertex is. Right? It's not asking us for x, but we don't have to find it, right? They want to know the y. That when we're done, we know we're done because we have the y-axis, the y coordinate of the vertex. Okay. So in math terms, this is the question. This is our task. Right? So we take the information they're asking for, which is in English, right? And they say, well, what's the question in math? Find the y value of the vertex. So now our job is to say, well, how do I do that? Okay. Can we just find the y value of the vertex, or do we have to do something else first? Do we need other information in order for us to find y? Can we just do y straight away, or do we have to go and do something else first? Anybody?
We already have the y.
We do? What's our y?
0.12.
What is this, Peyton?
1200s.
Yeah, but what is that? What's that represent?
The y value. The height.
It's not the y value. It's the y what?
Intercept.
It's the y-intercept. That's here, dude. Right? We're not looking for this.
Ah, shoot.
We're looking for that. Right? We do not want that. Okay? We're looking for this point. How do we find the y value of the vertex? Did it yesterday. We just did it a minute ago. How do we find the y value of the vertex?
We have to find x and plug in x.
Find x first, yeah, plug it in. Yeah. Can't just find y, we have to find x first. So how do we find x? You're supposed to know this. I asked you guys to know this. What's x equal to? Right, Evan? Negative b over 2a. Okay. So what's our b value? What's our a value? What's our b value?
.84.
84. And what's our A value?
Negative .03.
Okay. Obviously, we're not doing that in our head. Okay. We need to type that in the calculator. Now you need to be careful that, just like we are talking about with the last problem, you need to be careful how you type this in the calculator. All right, so I got 0.84 divided by 2 times 0.03. Sorry. So if I just say, negative 0.84, right, divided by 2 times negative 0.03, okay? That's the x coordinate of my vertex. 1/100th of a foot. Did the kangaroo jump 1/100th of a foot? And that doesn't make any sense. Okay, and look at the way that the calculator typed it over there up in the top left. Okay, is that what I wrote down? Okay, no, it's not how I wrote it. Okay, the calculator didn't understand what I typed. I wasn't being careful. We needed negative 0.84 divided by 2 times 0.03, negative 0.03. That multiplication has to happen first. We need to tell the calculator, we need you to multiply the 2 times the negative 0.03 first. All right. Well, I didn't tell it that, so it didn't do that. So this is how you tell it to do that. Okay. When you're dealing with division, especially in calculators, you have to be really careful about how you talk to your calculator. Okay. What exactly needs to happen first in order to make the division right? Okay. And that multiplication has to happen, then the division happens. And then we get something that's more sensical. Okay, 14 feet. Kangaroo jumping 14 feet. Sure. I don't know how far kangaroos jump, but that seems more reasonable than 0.1 foot. Okay. So when you make a mistake, it should be pretty obvious. This is something I was talking to you guys about yesterday. There's no way you should be accepting that first answer from yourself. It doesn't make any sense. Okay. So pay attention to how you talk to your calculator. It's very easy to type stuff in wrong. Okay. So now we got 14. Okay. So we found the x value of the vertex, right? That's not what we're after. We're after the y value. Okay. I think Peyton said that already. We need to plug in. So we're going to say, what's f of 14? Okay, so we're going to take negative 0.03 times 14 squared plus 0.84 times 14 plus 0.12. Okay, so I need to type all that in my calculator. I'm not going to do that in my head. Okay, but you got to be careful how you type it in. Okay, so let's get that typed in. Negative 0.03 times 14 squared. I'm pretty much going to be typing it the way I wrote it because those parentheses are there to help. Plus 0.84 times 14 plus 0.12. Okay. 6. Right? That's the height. That's the y value, right? Does that seem reasonable? 6 feet in the air. Okay. Kangaroo, they got legs for days, right? Nothing crazy going on there. So it seems reasonable, right? What if you make a pretty easy mistake? What if you forget that negative there at the front of the problem? I couldn't affect anything too much. It's just a negative 0.3. What the heck could that change? 17 feet in the air? That seems a little sketch, right? Probably not jumping that high. Despite changing one sign, right? Signs have such a huge effect on these problems. Okay. Again, you shouldn't be accepting that. It doesn't make sense. Whether or not you can figure out what you're doing wrong is a whole different thing. Okay. But at least you should be knowing that you have a question to ask. This doesn't make sense. Here's what I got. Doesn't make sense though. What's going on? Okay. I want you guys to be evaluating what's going on. Do your answers actually make sense? Okay. And how do we finish that? So we've gotten the number we want, right? We wanted the y value of the vertex. We've got it. Okay. What I want you guys to do is answer your question with a short sentence. What was the question about? It was asking what the max height was. That's fine. Okay. Anything you want to ask me about right now with this? Let's look at this one. Yeah. So you guys playing along at home that are writing this down, what do you need to write down, right? So we don't need to know that we're talking about a bridge, like far as math goes, just pay attention to context later though for yourself. We definitely want the function. Okay. What does X stand for? So X is the distance in meters from the arch's left end. Y is the distance in meters from the base. That's a really weird way of saying the height, right? Like if I say what's the distance from the top of my head to the floor, it's really the same thing as saying, what's my height? So if you want to say, y is the height in meters, it's certainly a shorter way of saying that. Okay. Then what's our questions? Okay. First question, what's the maximum height of the arch? Okay. So we got a bridge, got an arch being used as a support. Okay. How high does the arch go? Pretty normal thing to ask. Okay. So if we think about what that might look like, again, if you want to draw a quick drawing just to help yourself out, got an arch. Okay. It is completely up to us where we put the axes, but I've talked about what's probably the best thing to do, right? You have the ground, since that's where the arch starts and ends on the ground. It talks about the distance from the left end. Okay, so we put that y-axis on the left end. Again, what that allows us to do is make those distances positive. I certainly could talk about negative distances, but it just doesn't make as much sense. The numbers don't care, okay? But to us, it just doesn't make sense. Okay? What's the y-axis represent? Right, it's height in meters. This was distance in meters. Okay. So what's that first question asking us to find in math? How do we translate the question into math? What's it asking for? Okay, Tatum's saying to find the maximum, we need to find the vertex. What about this, Tatum? What's that referring to when it says height? Vertex is a point. So what do they really want from us? Which one? Gotta be more specific than that, Evan. Evan's saying the coordinate of the vertex. You guys can't see what Tatum's typing, but so we want the y value of the vertex. Okay? So being specific there, it's the y value of the vertex, not just the vertex itself. Okay? So to answer the question, that's the part we need. Right? Once we have that piece of information, we're done. Okay? Well, how do we get there? Okay? Same thing as last time. Right? So if we want to find the y value of the vertex, we have to find the x value first. Okay? So what are we actually being asked to do? Find the y value of vertex. How do we do that? We start by finding x. Okay? Zach, how do we find the x? What's our formula?
B over 2.
Okay. Natalie, what's my b value? Okay. And Avery, what's my A value? Okay. So we need to type that in the calculator, right? But when we type in the calculator, we're going to make sure we put parentheses around that. Okay. So negative 1.68 divided by 2 times 0.016. All right. That wasn't right. Ouch. What did I do? I didn't close my parentheses. That was stupid. I didn't put parentheses. I just said it. I didn't do it. Parentheses. But notice how that number is just junk, right? It doesn't make any sense. Oh, I just got negative 0.52 feet or meters. What the heck? How the heck can it be going negative 52 or feet, meters, whatever it is? That doesn't make sense. Okay. What do I do? Right? I didn't put a negative there. Do I really need to go back and put a negative there to figure out what the answer is supposed to be? Or am I just wasting my time? Okay. I know the answer is supposed to be positive. I got a negative. I can see that I left a negative out of the problem. Why the heck do I need to type it again? Okay. Why did I even type the negatives in the first place? 2 negatives is always going to give me a positive. Did I really need to put the negatives in there? Was that the question? Is this positive or negative? No, that wasn't what we didn't know about it. What we didn't know was the value. Okay? There's things you guys can do to make this easier for yourselves. You don't need to type the negatives in. If you know the answer is positive, okay? So 52.5, right? Does that seem reasonable? Okay, it's a bridge, 52.5 meters. That's a pretty long distance. It's over 100 feet, 150 feet. Okay, but bridges are long. It makes sense. Right? It's nothing unreasonable about that. So we know that this is 52.5 meters that way, right? But now we need to figure out how high it is. Okay, so now we need this. Okay. So let's plug that in. All right, step 2. So f of 52.5 negative 0.016 times 52.5 squared plus 1.68 times 52.5. Good Lord. Okay. Okay. Does my answer seem reasonable? Is there a chance I messed it up? 44. Last one is 52. Right. We're talking about how high the bridge is. It's 52 meters to the vertex, 44 meters up. Again, that's over 120 feet, but we're talking about a bridge that's over 150 feet long. Maybe it's over 120 feet high. It doesn't seem crazy, right? You always go back and check, check your signs. Again, that idea, if you drop that negative off on accident, okay, that's, 132 meters, which is, like 400 feet in the air, right? That's starting to get pretty crazy. Okay, so 41.1 meter or 44.1 meters. Okay, so we found the y value of the vertex. So it's to have the max height, right? That's what the question was. I'll answer the question with a short sentence. Okay. I have another question to answer though. What's the distance between the ends of the arch? Okay. So what is this question asking about? In math, how do we rewrite that question? What does it want us to find? X-intercepts, yeah. So distance, that's an X question, right? If we know how far apart these points are, that would be the distance, the length of the bridge, right? Or length of the arch. So this is an x-intercept question. Really, it's this x-intercept that we're really interested in, that one. And I know this one's at 0, 0 because that's where I put it. Where is that one? Okay, so this is an x-intercept question. Okay, and specifically, it's the x-coordinate because we know the y-coordinate is 0. Okay, so you guys actually don't know the math in order to do, last week I showed you guys when we were doing the vertex form, we plugged in 0 for y and you guys were able to solve for x. You guys actually don't know the math right now to solve this equation that way. Okay, and so we're having to give you guys very specific problems that you have a different way of doing it, where the y-intercept has to be at 0, 0, right? Notice how there's no y-intercept here, right? There's no value here, so we know that's at 0, 0, okay? If that's true, what we can do, right? What do we know about the vertex? It's right there in the middle of the parabola. So if I know where the middle is, then I should know where the other end is, okay? So because the y-intercept is 0, I can take that number and then just double it. And that gives me my further x-intercept, okay? That's all I have to do. Okay. So we're going to take 2 times 52.5, which is 105. Short sentence. We should have been able to get at least another problem done, but we spent a lot of time just sitting around and being quiet. So you guys are going to get less examples